Hello, good humans, Ruoya here, and today we're going to be doing a free response question from the 2002 AP Calc BC exam. To be specific, we'll be doing question number 6, which deals with a relatively straightforward Maclaurin series. Ready? Let's begin. The question gives us a function that is defined like this. F of x is equal to the series from n equals 0 to infinity of 2x to the power of n plus 1 over n plus 1. And helpfully, they have given us the first couple of terms, which are as such. Part A asks the following. Find the interval of convergence for the Maclaurin series of f and justify your answer. When they say justify your answer in this problem, they simply refer to explaining which series tests you have used to deduce convergence. More on that later. We begin with the ratio test, like most Taylor series. Take the limit of n as n approaches infinity of the n plus 1th term divided by the nth term. Finding the general term for the n plus 1th term is as easy as sticking plus 1 to the original series we started with. And dividing here is done simply by flipping the fraction upside down, thus using its reciprocal. Simplifying, we get this fraction. Don't forget the absolute values. And since the limit can be brought into the n terms, we do just that. Here the limit is obviously just 1, so we're left with the absolute value of 2x, and since this must be less than 1, we have negative 1 is less than 2x is less than 1, or just negative 1/2 is less than x is less than 1/2. Alas, as you likely already know, ratio tests can only get us so far. Without definitive knowledge of what happens when the ratio is exactly equal to 1, all we can do is plug in endpoints and finish off traditionally. Time to pick up the slack. Plugging in negative 1/2 will turn that 2x to the power of n plus 1 term into a negative 1 to the power of n plus 1, which makes this an alternating series. Since the limit as n approaches infinity of 1 over n plus 1 is equal to 0, and of course 1 over n plus 1 is a continuous decreasing function, we can conclude that this series converges by alternating series tests, and thus negative 1/2 is included in our function's convergence bound. Plugging in 1/2, on the other hand, completely removes this upper term. This leaves us with a simple series of n equals 0 to infinity of 1 over n plus 1. And here's a little trick you can do to avoid the ordeal of limit comparison tests. Since n is only written in terms of n plus 1 on the left side, instead of saying this, you can say the sum is from n equals 1 to infinity of 1 over n. This works simply because on the left side, we don't have the terms 0, 1, 2 for n, and on the right side, n goes 1, 2, 3, etc. And going from left to right, all we did was add 1 to every single n term in the series. And now just stating diverges by p series should be wholly enough to eliminate 1/2 as a point of convergence. We're left with negative 1/2 is less than x is less than half for our finite answer. On to part B. Here we are left to find the first 4 terms, as well as the general term, for the Maclaurin series of f prime of x. Since we are given the first 4 terms of f, simply taking the derivative of them, we'll easily slide in f of x with a power rule. Not much to say about that. As for the general term, the key is to remember we are taking the derivative of the main term here with respect to x. Remember that, and everything will be fine and dandy. The exponent comes down and cancels the denominator, and don't forget to pull out another 2 as a result of chain rule. Our ultimate solution is 2 times 2x to the power of n, which I'll write as a series for convenience. And since f of x's first term was not a constant, all terms are accounted for, and the series begins same as above with n equals 0. Part C. Let's solve. for f prime of negative 1/3. Right off the bat, since the question asks for the exact value of a series, we should expect to see either a geometric series or a p-series. Plugging in negative 1/3 to our Maclaurin series gets the sum from n equals 0 to infinity of 2 times negative 2/3 to the power of n. A constant to the power of an increasing value is most certainly a geometric series, and since x is within our interval of convergence, we can go straight into it. The formula is a over 1 minus r, and here r is just negative 2/3, so we have 1 plus 2/3 or 5/3 in the denominator. A is our first term, so plug in 0 for n and you get 2 in the numerator. Divide and our final answer yields an elegant 6/5. Note that according to the scoring guidelines, even if you got the wrong answers for f prime of x in part B, you can still get full credit in part C for accurately solving the summation of your own series. Welp, that'll be all for now, folks. If you'd like some extra practice on Maclaurin and Taylor series shenanigans from some FRQs that aren't quite as old as this one, check out the description below. Hope you enjoyed.